So in this part of the problem, we have some information. We have that the mass of the object going around the circle is 5 kilograms. We also know that it takes a time of 5 seconds to travel 4 revolutions. Now, what we can get from that is we can get the period, because period is defined as the time per cycle. So that would be 5 seconds per 4 revolutions, which would give us a period of 1.25. And the reason why we need the period is to find the speed. We need to know the speed that it's moving around in this circular path. And to find that, we would use the equation 2 pi r over the period. Now, before we can plug everything into this equation, I need to finish listing out what the problem gives us, and the problem also gives us that the radius is 8 meters. So, plug in the radius, plug in the period, and we get a speed of 40.2 meters per second. So, from there, I want to draw my free body diagram, and I want to know the tension force of this mass as it's going around in this vertical circle at the 8 o'clock position. So at the 8 o'clock position, that's my 9 o'clock, so at 8 o'clock position, I am 30 degrees below the 9 o'clock position, because each hour is 30 degrees on a clock. So when we draw our forces, we have the weight, which is straight down to the center of the earth, and we have the tension, which is what we want to find. Now, the tension lines up with the acceleration, because the acceleration is also pointed towards the center of the circle, which means I'm going to make the axis line up with the tension, because that also lines up with the acceleration. I'm going to call that my y-axis. And then I'm going to tilt, which means my x-axis is going to be tilted. I need to break up the weight into something that lines up on the y-axis and something that lines up on the x-axis. And if I'm using the angle there, then that would be mg cosine theta and mg sine theta. Now that angle is kind of tricky, because the 30 degrees, right? The 30 degrees is right there, but if we think about the angle we're looking at, we're actually looking at that angle right there, which is the one that corresponds to the one in our triangle, which is 60 degrees. So when we use cosine and sine, we're going to use 60 degrees. Alright, so let's now set up our sum of force equation. Right, Newton's second law, so sum of the forces equal MA. And we have tension pointed into the circle. We have mg cosine theta pointed away, so it's going to be negative. And it's moving in a circular path, so A is going to be replaced with B squared over R. And the acceleration is pointed in what we're calling our positive direction. So that means, when I rearrange the equation, that the tension is going to be equal to mv squared over R plus mg cosine theta. And we have the mass, which is 5. We found the speed, which is 40.2. The radius is 8. The mass again is 5. The acceleration due to gravity on Earth is 9.8. And we said that the angle was 60 degrees. So, when we calculate this out, the first term is going to be 1010. Wow, 0.025, and the second term is going to be 24.5. So we have to add both of those up. When we do, we should get our answer, which is 1034.525